closed on this site on the December 2020. And after that, hence this bridge is the world's highest railway bridge. It connects that there was already a This is the view of the before commencement of the work. So when we went there to the site, first time myself, we have to go in a boat and then climb the hill. So that was the time, when we could witness a lot of challenges, because this is a younger Dolomitic limestone, so that there were a lot of cavities as big as almost 8 feet cavities. Also, while animals also live there. This yes, we have to climb up and check up and then start the investigation. So I was fortunate to get involved from the very beginning of this project. And this is the overview of the whole. We need to climb up to the now we imagine now there's no road either end of the bridge. This is the river Chenab. So the either end there is no road at all. This was the challenge. This site, that's how it took a lot of time. So what are the geotechnical issues? Starting from geotechnical site characterization, identifying the properties, then foundation design, major problems, low geotechnical investigation, continuous are crucial components of the system. As this structure is very vital component for us to connect to the source of energy, I will have this, and a lot of So, coming to the geotechnical issues, friends, it's a highly jointed rock mass which is predominant in Himalayan region where the ground is subjected to severe tectonic activity due to pushing of the Gondwana and invasion. This is the plate boundary. Highly jointed rock mass is close to the soil strength, kind of thing, and behavior is still drawn by the joint character. Neither a rock or a soil. So somewhere between the understanding of the material behavior and connection with the properties is a big challenge for all of us. The analysis of the slopes, the assessment of safe building capacity, of foundation was a big challenge to simulate this. And then construction activities. This is a huge project spanning almost 20-22 years. So our challenge was, how do we really learn from what we do there and then modify the design as we go. And this is the behavior of the mass which is existed there. As I told you, it's a younger dolomitic rock, very complex in scale, features, joints, fractures, it's all at different scales. It's also influenced by the joint frequency, type of joints, and also the filling in the joint, orientation of joint roughness, and type of joint filling and confining pressure is also a very important aspect in modeling this particular joint. So obtaining the industry sample is a challenge for us in this site because it's a hot mass. Testing them under laboratory condition was, again, we didn't have even a laboratory facilities to test such large samples. So the strength and deformation behavior of hot mass is just what dependent here. So we also, as I explained to you, it is a phase excavation process to reach to the foundation levels where we wanted to put the foundations. So a lot of modeling has happened over the large number of years. Just to give you a picture, where is this site? You can see Jammu is here, Jammu, Udhampur, and Vaasa, which is like Banihal is about 111 kilometers, which is marked in red color, and the point where Chenab Bridge is located right in the middle. So you can see many rivers are flowing across, wherein we need to create bridges and then let the entire structures with a large number of Chenab River is very deep. I told you, the problem statement in this particular problem that is close to us was, they said in highly jungle landmass, predominant in the Himalayan region, the ground is subject to severe and it is close to soil strength, so some of the properties in that complex. And what is still gone by this. Analysis of slopes and assessment is very fast. Thus the analysis becomes very complex and expensive because you have to go after the properties because it's continuum to discrete. And how do we do this? Our objective was to determine the impact of rock and rock mass parameters for the analysis and design of this program. Then just to calculate parameters, determine the stability of slopes and suggestion for the population analysis of stabilization models. Then design the foundation ledge. So that is safe. Lay down the principle as the design and as you go approach. You can test every material that has to be tested out. So when we excavate only, we will even expose the material. So that time the tests are all being done and so this is the very design. Tell you this is done. It is done.
Sometimes
Large
what I
projects design
say,
as you go.
there's no one I can turn.
We also know this as an intellectual
And I know all the feelings that we shared out in the past. And I know your relationships are never meant to last. And I'll take some time, but I'll be alright. Keeping on. I know time's hard to but I had enough.
it establishes the guidelines within between these two. What is the uniqueness of this particular switch? It's a very complex geological also a big challenge. The steep slopes and required extensive structural and also excavation. So that excavation, the material should not fall into the river and block the way. It's another big challenge. Deep foundations, I don't think it is a deep because foundations are not on the surface. They are embedded, and we can somewhere between again foundations are not either a shallow foundation or a deep foundation. Somewhere embedded. So on a steep terrain, very steep, it's almost like 67 to 70 degrees. Foundation have to be securely embedded into the slope of the rocky terrain with customized excavation and blasting. So this blasting is also continuously done, and see that this controlled. So seismic and wind load integration into the groundwork is another big challenge, and slope and foundation designs uniquely address seismic and wind loads. And should be foundation itself. Foundation treatment whether grouting, This is a steel arch they have chosen. This is an arch bridge. So first of its kind steel arch railway bridge in a high seismic zone in India. They have not railways have not done this. So that was the big challenge for them. And use of weathering steel, material selection for the steel itself. One lot of steel they procured. And it was because of the time gap started to so they have to change the entire steel procurement what they have done. Please remember, taking the steel on the side itself is a big challenge. There are no roads. Design like this is lot of insurgency, and it could be some terrorist put the so some of the piers, even if it is blasted by explosives, the bridge stood strong. That's the other important criteria from the blast resistant design. So that's a very unique thing due to strategic importance. The bridge was designed as a blast resistant, highly unusual in a civilian railway. So railways would not be used to this. So the design speed is also, they wanted to, even though it is a single line, it's not a double line, and it is trains moving at 100 km per hour should carry heavy loads requiring robust design standards usually reserved for major rail corridors. So, and most importantly is the remote location without any accessibility. All materials, equipments, and workforce have to be transported to an extremely remote. And also remember, the truck sizes are also limited. You cannot take a long body trucks there. There is no way it can turn. So this was a big challenge. Either they have to move with cranes and cables, but depth is very high. It's almost like 359 meters above the riverbed of Chenab. So even if you bring through the river, almost 400 meters, you have to lift it. It's a very, very big challenge for them. So you can see whatever they have done there in that project is a very unique project. World's highest railway bridge, wind tunnel tests, incremental launching, and a combined circular and a transition curve, because this is a two part of bridge. One is the arch bridge, which I showed you, which is a steel bridge. The other part is a concrete one. So it is transition into the arch bridge. So it's designed to resist contact blast loads, and they have built a cable crane, which is again world's largest cable crane. So the capacity at which it can pick up, and indigenously developed a cable climbing crane for the erection of pylons was also done. Every step what they have done there is very innovative. Even grouting, because they used to simply grout initially, they all learned with very hard practices what they did at the site. Continuous grouting, and lakhs of cement bags were pumped in, but they couldn't find out where it went. So finally, I would like to just highlight to you on the piers are supported on foundations on slopes, particularly the left side, S10 to S40. They're not 10 and 20, 30, 40. 4 of them are supported at the ground, and the piers were connected directly hanging. And S50 to S8 again, they are founded on the valley side. You can say that is a viaduct portion and an arch portion, and also that's not a straight line, it's a curve. Okay, the viaduct portion is in a curving, it comes and joins the arch span. That's a big challenge for them to really build anything by incremental and construction wise. Friends, so you could see the slopes were, so the Chenab Rail Bridge uses actually 17 spans supported by both steel and concrete piers. It's a combination of steel and concrete piers. So with the highest steel pier reaching approximately 130 to 133 meters, and concrete piers reaching to about 49 meters height. The height of each pier is varying as well. So you could see, so before finalizing these slope profiles, actually, many alternate slope profiles were done as early as 2005. And 2007, after doing all the analysis with international experts coming in, and they wanted to change the location of the bridge. They said it is not feasible to build a bridge here. And there are a lot of deliberations, and both structural engineers, geotechnical engineers, and many railway engineers sat down together, a lot of discussion. Finally, the same location was accepted because they were worried about the stability of these slopes. But I made only one remark on this. These slopes are so large, whatever bridge they're putting, it is like an ant on the elephant. Very similar loads, whatever, if you go to the closest point of the bridge, then your loads are very high. But if you look at the entire slope, because they were worried about the global stability of this slope itself. So if you look at that, the load coming on this entire hill was like an ant load. So then, a lot of deliberation, we accepted. So how did we finalize these slope profiles is a big challenge. We looked at accessibility, joint blocks, slope height, width of berms, location of piers. It also, because structural component has to come in. And then height of the piers, all that has been taken while deciding the cross sections. So you can see now, almost 6 lakh cubic meters was excavated, has to be excavated to reach those profiles. And rock bolting almost 33,000 running meter, and shotcreting is about 80,000 square meter on the slope. Yes, 2-3 minutes. After excavation, you can see the right side, it's a height of 215 meter with 4 foundations. That is the left bank, and this is the right bank. Again, similar numbers, very large rock bolting, shotcreting, excavations. This is the uniqueness as we go along. And what is important is to understand is the approach roads. Almost close to about 2.5 kilometer approach roads on either side has to be cut, excavated, and reach those locations. So we can clearly see how was the reach, and look at the slopes. On that we have to move all the materials to the site. That's a very, very great challenge for us. And you can see the excavated slopes, how we shotcreted them, and how it is clean, and geological mapping, and fabricated rock bolts. And you can see how the rock bolts are driven. You can see installation of rock bolts, and final, they're all like installation slope below the one of the, this is only one, the picture of below S60. Similarly, have to be done at S10, S20, S30, S40, S50, S60. Almost, challenging is all the 8 foundations which are coming on the slopes were a challenge. So I will, I'll just, for a geotechnical engineers, I'll just highlight 2-3 slides and then close my talk. So our all investigation is logging of the surface. That means as you excavate, you have to log it, understand, and this is also done some pits on the surface at the founding level, and there were 2 drifts were done, tunnels basically, small tunnels, which will be actually subsumed when you excavate, to understand how is the rock material inside. So that is the 2 tunnels, one at S40 and one at S50. You can see the joint orientation. There are 4 different joints along with that, and this is the log. And geological data is clearly highlighted to us, highly fractured dolomite. Spacing is 20 millimeter to 500 millimeter. That's the beauty. So huge blocks are also there, but small. But these joints filled with silty sand and silty gravel. Presence of open joints and cavities are also there. RKD is only 0 to 10%. And then RMR is 35. So very weak rock. And UCS value, you can see, varies also, 16 megapascals to 62 megapascal. Permeability is more than 50 lugins. So actually there was it is a dry, almost dry, because slope was draining into the river. So I will skip many of these, but investigations, what we have done at the site is, you can see now, plate load test, in situ box shear test, borehole data, and through RQD, UCS, RMR, and everything, settlement characteristics, slope stabilization, all are being done. And finally, the implementation aspects is the key to success is discipline here, because if I do anything, all those equipments will go down 300 meters down. There are no barricades, nothing. Whenever we used to go to the site, we have to close our eyes, sit down in the jeep, and the fellow used to take us. He is very confident, but we were not confident. So strictly follow the contours during excavation so that reachability is easier, and design as you go, validate the design assumption as the excavation progress, using sophisticated equipment, and completely entire project is instrumented now. You can see the displacements, strains of every foundation now, okay, using satellite data as well as real sensors. It's one of the very important projects where a lot of instrumentation has happened. Final slide. It's more than just a transportation corridor, friends. It's a symbol of national integration for us, because Chenab Bridge connects to Jammu and Kashmir. It's a critical, those who live in this part of the world will understand how it is important is, and redefines what is possible when a nation dares to dream and its engineers resolve to deliver. For students and young engineers across India, this bridge must serve not just a structural landmark, but as a living classroom. So we have also, through All India Council for Technical Education, allowing students to visit this site. We can get permission so students can visit the site. True strength of engineering lies not in the textbook alone, but in the courage to take impossible odds. And that is why I titled my talk like that. And finally, it inspires generation to come to reach higher, dig deeper, and build stronger, because India is yet to be built. Let's honor not just the bridge, friends, but the countless bridge builders who made this marvel a reality. Thank you very much. Namaskar.
Thank you so much, Prasitaram. Truly wonderful. I think we'll pass on to the next lecture because of shortage of time. People who would like to discuss can do it over the plate of lunch which follows after this session. Thank you very much.
Thank you, sir. To hand over the memento to Professor T.G. Sitaram, sir, I invite Professor M.R. Madhav. Now we have a presentation by the title sponsor from Sunny Sankla Group.
We have two presentations by the title sponsors, but for whose support this conference would have taken off. But we request your support in trying to save a bit of time. Though originally they gave you 10 minutes, may I request you to finish in 7 minutes, please? Thank you.
Can I have the cue, please? I'm sorry for the delay, but the technical team is still sorting things out.
Can we get the presentation, please?
Good afternoon, everybody. For over 3 decades, the Sunny Sankla Group has stood for growth and with purpose, building businesses that just don't profit but progress society. Today's story is about how legacy is evolving from shaping industries to driving India's clean mobility. Our journey began with industrial warehousing developments that powered Pune's growth corridors. Over time, we expanded to education, real estate, sports and entertainment, each venture strengthening the ecosystem around us. Every legacy begins with visionaries. Shri Motilalji Sankla laid the foundation, an entrepreneur and philanthropist whose belief was simple: business must build lives. Mr. Sunny Sankla, with global experience in logistics and retail, brings an international perspective to Indian expertise. And Mr. Atharva drives next chapter with his tech-driven leadership and focus on innovation. Our mission is clear: to engineer India's clean mobility with future, with world-class made-in-India EV charging solutions. The group today thrives across sectors, from industrial warehousing, real estates, to leasing, education, EV charger manufacturing, and even sports and entertainment. This diversity is our strength. It allows us to build interconnected ecosystems with industry innovation and community progress together. Our philosophy can be summed up in 3 words: people, planet, progress. Launched in 2021, Sanat Industry has a bold step in e-mobility. Born from conviction that India can build your own future, Sanath is not just assembling chargers, but building confidence. It's innovation rooted in sustainability and driven self-reliance. Our facility in Mumbai produces chargers ranging from 3.3 kW units to 240 kW DC fast chargers. Every component is designed, engineered, and assembled in India, reducing import dependence and strengthening local capabilities. When we say made in India, we mean it in spirit and in structure. Technology is heart of Sanath. Our hardware line includes AC and DC fast chargers. Also, our system includes software, CPMS, and mobile apps, ensuring seamless management, analytics, and user experiences. What sets Sanath apart is attention to both design and dependability. In short, its performance wrapped in simplicity, making EV charger effortless for business and end users alike. For our partners, installing a Sanath charger isn't just about its power, it's about positioning. Every installation becomes a statement that your business is ready for tomorrow. Sanath reflects in the true spirit of Atmanirbhar Bharat. From design to assembly, everything happens here by Indian engineers with Indian technology. We are not just reducing imports, we are creating opportunity, nurturing skills, and exporting excellence. For investors and partners, our models offer flexibility. Looking ahead, our roadmap is ambitious, yet achievable. We plan to deploy about 10,000 chargers by 2027, integrating solar and battery systems for self-sustaining hubs, expanding high-power corridors across India, and collaborating with real estate developers, fleet operators, and smart city projects. As we grow, we will take India's technology global, exporting not just hardware, but model of clean energy leadership. In essence, the Sunny Sankla Group's journey is about building legacies and driving future. From industries that powered India's growth to innovation that now power its mobility, our purpose remains the same: to build with vision and to build with generations. Thank you. I'm just going to play a short video about Sunny Sankla Group. Can we have the view?
What began with pioneering ventures in energy and industry has evolved into shaping Chakan's industrial backbone, the Sunny Sankla Group, where growth is always driven by purpose. Over the years, the group has expanded its horizons across industrial warehousing, real estate, leasing and holdings, sports and entertainment, education, LMS foundation, and EV charger manufacturing. Ventures that continue to empower communities while building industries of the future. Today, that same spirit drives the group's boldest step forward in clean mobility with Sunearth Industries. Carrying this legacy forward, Sunearth Industries represents the group's boldest step into the future. An end-to-end sustainability solutions provider, Sunearth is engineering India's next-generation EV charging ecosystem. With chargers designed, manufactured and assembled at its Mumbai facility, proudly made in India under Atmanirbhar Bharat. More than 2,400 chargers installed across 80+ locations. Part of India's 26,000+ public charging stations, MOP/BEE 2025. End-to-end ecosystem, hardware plus CPMS plus mobile apps plus solar integration. Fastest growing EV infra provider built on uptime, adaptability and affordability.
At Sunny Sankla Group, our philosophy is legacy with purpose. From real estate and industrial warehousing to education and sports, every venture has been about empowering communities while creating industries of the future. With Sunearth, we are challenging that same conviction into clean mobility, delivering EV chargers that ensure uptime, inspire trust, and represent India's Atmanirbhar vision. We are not just enabling EV charger adoption, we are laying the foundation for India's sustainable growth story.
At Sanath, my focus has been to fuse technology with sustainability. With expertise in software, solar energy, and carbon economics, I ensure our chargers are not just reliable but also future ready. Every unit is designed, engineered, and assembled to global standards, yet proudly made in India. For us, innovation and execution go hand in hand as we build the backbone of India's e-mobility future.
At Sanath, sustainability drives our EV transition. Energy audits refine our processes for maximum efficiency, moving us closer to a zero-emission world.
For businesses, Sanath is more than a charging provider. It's a growth partner. Every installation brings not just energy but opportunity. More customers, more trust, and more sustainable outcome for enterprises and communities alike. Our vision is to make charging infrastructure an enabler of business growth and a catalyst for India's transition to a cleaner economy.
Why choose Sun Earth? Why do leading businesses and EV owners choose Sun Earth? Because we deliver more than just chargers. We deliver innovation that works in India. Lightest charging gun, effortless handling for all users, OCPP compliant, open standards for universal compatibility, IP56 certified, dust and water resistant durability, smart load management, efficiency for grids and businesses. Proudly made in India, designed, engineered and assembled in Mumbai. ARAI certified. Sunny Sankla Group. Building legacies, empowering sustainability and driving India's electric future with Sun Earth Industries.
Thank you very much. So may we have the next title sponsor from J. Kumar? Yeah.
So I think they are not here.
Okay,
So
thank
now
you.
I request Ms. Manali Sankla, the Vice President of Sun Earth, to come forward and accept a token of gratitude from Indian Geotechnical Society and the organizers of Geotech Asia 2025. Requesting Dr. Anil Joseph, Dr. Ashish Juneja, and Professor Dasakamurthy to join Dr. Anil Joseph on stage. Sunny Sankla is a title sponsor of Geotech Asia 2025. Thanks goes to Sunny Sankla Group for being the title sponsor of Geotech Asia. I would request a representative from J. Kumar, if they are here in the hall, to kindly come forward for the title sponsor slot. Since we don't have anyone from J. Kumar, I would request the co-chair to kindly invite the speaker for the next session.
So can we now have Professor Changchuk Yu, please. So we will have a lecture on smart technology and AI-driven geotechnical design, progress, challenges, and future directions. Over to you, sir. Thank you.
information technology. Without that, we cannot survive right now, right? Without phone, we can do anything today. So here, information technology include hardware, software, and other equipment. But here, my presentation only focus on software. So you are seeing in the screen the information technology that we are using for our routine geotechnical design, numerical modeling, GIS, recently artificial intelligence, and digital twin, and so on. So in my university, my research group has tried to incorporate this information technology into routine geotechnical design. And more recently, we are trying to incorporate a more recent satellite-based monitoring program, which is we call INSAR, interferometric SAR radar aperture technology for ground monitoring. And together with AI, we can monitor and analyze and do the master management. So all these information technologies bring together, we can do a smarter way for our routine geotechnical design. So this is my history of my research on this topic. And by the way, many of you might wonder, well, Chung Sik-kyu was the president of International Geosynthetic Society, and I'm the editor of Geotextile and Geomembrane. Hey, that guy is a geosynthetic guy, and what I'm talking about is AI. Yes, this part is another part of my research area, along with geosynthetics. So since 2000, I've been doing this work. I will walk you through my 5-phase research program until now, so that we can be on the same page. So I would like to give you more detail regarding phase 2 research. So in this research, we developed an approach that integrating deep learning into GIS so that we can do better design for tunnels and deep excavation and other engineering work. Why tunneling? Well, Korea has a mountainous terrain, and 70% of Korean land consists of mountains. So we have a lot of tunnels. We have built and also building a lot of tunnels. Total length of tunnel, 2,000 kilometers for road, railway, subway, tunnels combined. And conventional tunneling is the primary tunneling method, but these days, for urban tunneling, the TBM shield tunneling is getting more popular. But conventional tunneling is the major primary tunneling method that we are using currently. Well, as you can see in the bottom, Korea size is about 1/3 of India, only 100,000. I'm talking about South Korea, okay, excluding North Korea. It's about 1/3 of Indian the size. Also, the population, same thing. But we have putting a lot of efforts in constructing infrastructure, not only railway, but also roadway and tunnels and dams and so on. So we currently have 2 lines for high-speed railway. The blue line, which is we call Gyeongbu line, that is KTX. The construction began in 1996, and it put into service in 2004. The total length of the high-speed railway is 410 kilometers. So another line, which is we call Honam line, SRT, was put into service in 2017, and that length is about 250. Now, in the beginning, during the preparation planning stage, many people say, Korea is small, do we really need high-speed railway? Many people question, but now everybody loves it. That high-speed railway system turned Korea into one-day zone. In Seoul, you take the high-speed railway, you get to Busan, which is the second largest city, have a meeting, lunch, and come back in the evening. Okay? So it has become really important infrastructure. And during the construction of SRTs, which is second line, we have built 50-kilometer long tunnels, 50 kilometers. At the completion of this tunnel, that tunnel was ranked third longest tunnel in the world, after Gotthardbase Tunnel in Switzerland, and Seikan Tunnel in Japan, and third, Yulhyun Tunnel that I'm talking about. So we have a lot of tunneling projects. We had a lot of tunneling projects, and also we are building a lot of tunnels. So this is, as you might know, typical conventional tunneling design process. We do site investigation, we do rock mass classification, and we select support patterns based on either RMR or Q system, and then we evaluate the stability of that design based on numerical analysis. If it's okay, we go next. If not, you have to change the design, and this is iterative process. So this process, if let's say we talk about 50-kilometer long tunnel, that is a lot of work. It is time consuming and computationally intensive work. So we try to think what can be done. So time consuming, iterative process, a lot of numerical analysis has to be carried out. So we try to find a better way, not new way, but better way to expedite the routine tunnel design process using deep learning, AI. Actually, we started 2004. We started deep learning at the time. And to do that, you need data, right? Big data. So we started to collect all the data. That was possible for tunneling because we had a lot of tunneling projects at the time. And in tunneling project is quite long, right? Few kilometers, sometimes 10 kilometers, 50 kilometers. So we need to manage your database. GIS was the platform that we can use for geodatabase management. So combine those technologies together. We tried to build a platform, GI-based platform, together with deep learning models, deep learning technology. Okay? So by combining all the artificial intelligence, big data analysis, we were able to develop a platform that integrates deep learning and other important IT technologies, as you can see. So big data, how we collected it? First of all, based on site investigation data, design documents, we collected from thousands of design cases. Okay, so you can see that we developed a database for different rocks, different rock types, for routine the design parameters, for example, deformation modulus, cohesion, and internal friction angle, and so on. We developed and tried to make something out of it. And also, based on the analysis of design documents, we were able to relate the support patterns with tunnel geometry and ground conditions so that we can use that as a big data to develop deep learning models. Over 1,000 design cases. We are still collecting it. And also, combining those data together, we were able to obtain the relationship between design conditions with support patterns. And also, we wanted to use deep learning as a soft computing tool. Okay. As I mentioned during the design stage, we have to do a lot of numerical analysis for different sections, right? That is routine analysis, not specific more detailed class A analysis. But during the design, we need sectional analysis for the return design. So we collected all the design documents, and sometimes we had to do additional analysis to supplement the existing analysis result so that we can cover a wide range of conditions. So after obtaining all those big data, we developed, at the time, deep learning was not the popular term actually. Artificial neural network or artificial intelligence was the term that we used. So we developed ANN support, which is deep learning, a model that gives you the support patterns once you input tunneling conditions. And also ANN predict, that is the software computing actually based on deep learning. So you give the input for the tunnel design conditions, then it gives you all the stability analysis. For example, for tunnels, crown settlement, and aligning the forces so that we can make design calculations. Now, as I mentioned, having those models is not enough. Tunnel is usually long, 10 kilometers, sometimes 50 kilometers. So if we implement that numerical model, the deep learning model into GIS, that makes the designer life a lot easier. So we try to develop an interface by using, we call it add-ins for the GIS system, so that by clicking, you get all the data. So actually, we at the time, we did a lot of work for developing deep learning models, as you can see on the screen. And at the bottom, you see the equations for the deep learning model computation. Actually, once you train the deep learning models, you get the bias and weights. Okay? That is all they are the matrix calculations. So we developed the interface coding and put it in the GIS platform so that you can actually do the computation within the GIS platform. So once you're putting all the deep learning models interfacing into the GIS platform, you can do all the calculation and show nicely visualized fashion. And also we implemented the building damage assessment technique so that if you click, it calculates the settlement at that point and do the building damage assessment for the regular structures and also underground pipelines as well. So this is the work done that I did long before we recognize artificial intelligence can help us do better design and do the analysis. So at the time, I'm talking about 2004-05, and we had the KTX, which is first line, Gyeongbu line of high-speed railway design. So we implemented, did my approach to the actual design and to see how well the suggested approach can be implemented into practice. So as you can see on the southern part of Korean peninsula, we had a very difficult ground condition. We had a lot of fault zone along the corridor, and the groundwater pressure, the level was quite high, and also it was urban tunneling. So, and also time is limited. So we need to find a way to expedite that process. So my approach was implemented. Okay. So at the time, it was big data-driven, AI-based tunnel design platform. So everybody was really happy about this platform. So before executing this approach to that particular project site, we had to develop we have to develop site-specific big data and then implement the existing, already developed program so that we do not lose the taste of the particular project site. Okay? So We developed another additional set of big data for tunnel design and support calculation model database, and then we retrained the deep model so that we can better estimate the project site problems. So this is actually 2003, the work, a long time ago. So we implemented this program. You can see the GIS visualized output. So all those calculation was done by clicking it. So we did not do any additional work to show that visualization, but within the GIS platform, just clicking one button, then you get all the results along the tunneling route. Tunneling settlement, groundwater depression, and building settlement, and so on, everything. So what we can do, we can identify the area of problems, high-risk area, so that we can change the design and we implement other mitigation measures. So this is an example of building damage calculation based on, probably you are familiar with the Berland building assessment method. We implemented that. We can show it in three-dimensional. So this was successfully implemented. So what are the benefits? It is logistical approach, okay? And also we can save a lot of time, and actually by implementing the developed approach, we could save 50% of entire design time frame. And also it is a rational design approach. Another big important thing is that once additional data become available, you can retrain the deep learning so that you make better the deep learning model for any project. And second phase, next phase was I tried to expand this approach to other more structural computation intensive problems such as TBM, segment lining design, and also deep excavation design problems. So this, you can see the typical design process of TBM segment lining design. Okay, we have to consider production and transient stages loading, right? And then loading for construction stage. And also final service stage, we do a lot of structural analysis based on the beam ring models, as you can see. So this is very kind of computational intensive process. You have to do the repeated iterative process to optimize your lining design. So I implemented this, my approach. So we collected and we did an additional analysis to relate tunneling condition with lining segment structure analysis result. Okay, I will show you how that can be implemented. So this is, we developed a AI-based structure analysis. We collect all the design cases, including different tunnel diameters, ground conditions, and groundwater pressure differences. And also we did the structure analysis for many, many different cases. And we developed the deep learning model that calculates the structure performance of segment lining, so that by clicking one button, you get all the data. I will show you later. And this shows you the developed system. So by clicking within the GI platform a button, you can call upon the program. And also GIS has all the geo database. So by clicking a section, it retrieves all the geological condition, ground condition, and building conditions, so that can be implemented in the design calculations. Okay. So these are the automatically retrieved the database from the GIS. You can do all the calculations. And you see that by clicking it, let me move it a little bit further. Yeah. This kind of calculation for the structural analysis is also AI-driven result. Okay? They are trained based on structural analysis results, or to get by clicking it, you don't have to do the structural analysis. By the way, this proposed approach was not for detailed design. You can use this in the preliminary design so that we can screen the possibility of important sections that we have to do analysis more. So I'm saying that this does not exclude the detailed analysis, but this is really good for preliminary analysis. Another approach, sinkhole problem in urban area. So this is really what happened due to the sinkhole. Okay. And sinkhole can occur due to leakage of sewage, and also that can be developed nearby deep excavation area, underground construction, and this is the collapse of convenience store nearby the deep excavation the site. So this is happening everywhere, not in Korea, but also probably in India too, right? So we try to develop a better approach. So first of all, you need monitoring, right? So we incorporated, as I mentioned, INSAR monitoring as a continuous monitoring without any monitoring devices. Okay? And also we incorporated artificial intelligence to predict future settlement. And also all these technologies brought into GIS platform so that we can manage all the data. So what is INSAR? I'm not going to go in detail, but INSAR is a technology for measuring surface displacement over time without any installing sensors. Okay? So we just need SAR data, satellite images, to generate the settlement. Okay? Now it has become very popular. Every year, probably, I have seen many papers coming from the India. So it has become a general monitoring technique for ground settlement. So advantage of INSAR is written in below. So unlike traditional measurement method, it is a non-contact displacement monitoring method that does not require measurement sensors. Only you need is satellite images. Once you do the analysis, process the images, you can have time series settlement over, as you can see on the graph, the number 3. Okay. So we have many satellite data. Okay. Satellite images, sometimes you have to buy, but European satellite image can be obtained freely. Okay, so it is actually free. The monitoring technique that you can use, right? So there are many satellites available. You need SAR data that you can use. So SAR interferometry technique is well-established technology that we can use. You can refer this technology in many literatures. Simply, we compare the satellite images and get the phase difference, and then we find
Professor
the
Yu?
settlement,
Sorry,
settlement displacement difference between the time. So I implemented this for a Korean, the international airport, to see if we can identify the settlement-prone areas. So I did 2003. So we need data prior to 2003. So we collected the satellite images from since 2014 with free of charge, and we analyzed it. Okay, you can see that these are the results. You can see the displacement velocity plot. You can identify the high risk of settlement. You can see the time series displacement so that you can find out where is the risk of settlement, okay? And you can, by analyzing the sections, you can the process for the displacement to find out the displacement trend and also building damage assessment, okay? And I put all that technology into GIS platform so that we can see the entire the settlement analysis, the progress within the GIS system. And this is probably the final slide. You can see that once we process the satellite images, and then it will generate the so-called the scatters, as you can see. And then by clicking the scatter points, you can see all the time series deformations. All you can see the scatters there. And then it shows the settlement over time. And then by combining deep learning, you can predict future settlement, as you can see. So by doing this, we can better do the asset management, and we can identify high-risk area and do the, you can exercise smart geotechnology. So nowadays, we just got the project about digital twin-based disaster prevention platform development project, and probably if there will be another international conference not in Goa, but probably somewhere in India, I love to present the current work so that we can share what the digital tool can offer for geotechnical engineering. Thank you for your kind attention.
Thank you very much, Dr. Sung-Suk Yu. Thank you for an interesting lecture. I think in the interest of the time, we would like to close the session, but I think we'll invite you.
Thank you, sir. I would request Professor R. Ayuthiraman to give a memento to Professor Chung-Sik Yu as a token of our gratitude. Thank you. I request Professor Dasakamurthy to come forward to hand over a memento to the chair and the co-chair of plenary session 2. Professor Ashish Juneja. Request Professor Kshitija to come forward to hand over the memento.
Forward to join us for lunch. We close the session.
Requesting the chair and co-chair to kindly accept the memento as a token of appreciation. Thank you, Professor Mark Bellows, for joining us on stage. Thank you all. Ladies and gentlemen, we will now break for lunch. Post lunch, we will start our session sharp at 2 p.m. We have parallel sessions post lunch. In this hall where we are all seated, we will have 3 separate parallel sessions after lunch break. Assembly of 1, we will have parallel sessions on the topic foundations and deep excavation. Assembly 2, we will have the topic earthquake and soil dynamics. Assembly 3, the topics would be practice, risk, and education. On the first floor, South 1, we will have parallel sessions on the topic geosynthetic engineering. Again, first floor, South 2 topics would be slope sustainability, slope stability, and landslides. First floor, West 1, we will have parallel sessions on topics ground improvement and stabilization. First floor, West 2, we will have parallel sessions on topics rock mechanics and tunneling engineering. Ground floor, all day, all night, we will have parallel sessions on the topics cold, coastal, and environmental geotechnical engineering. So requesting all of you to be back after lunch by 2 p.m. sharp in any one of these halls. Thank you all.